Welcome everybody, and thank you for joining our onboarding webinar for DNAnexus Essentials. My name is Carolyn Claude, and I will be your moderator for today. I'd like to spend a few minutes covering some housekeeping items and then go over our agenda. This webinar will be recorded and sent out to all registrants via email after the session, so you'll be able to get it in your inbox. You will see a Q&A icon at the bottom of your screen. If you have any questions during the webinar, please type them in this Q&A box, and we'll address all questions in the last 20 minutes of the webinar. Your speaker for today is Aniket Deshpande, Senior Solution Scientist on the Xvantage team. Aniket has a decade of experience working at companies including QIAGEN, Nome, Pacific Biosciences, and Novartis to accelerate precision medicine research and research in clinical settings. Aniket will give you an introduction to the DNAnexus platform architecture and launch into a demo of how you can use the platform to share and collaborate around your data, track data provenance, use projects and metadata. He'll take you on a tour of the tools in Workflows library, go into some running analysis using the UI and visualization, and then talk about additional resources to launch you on your journey with DNAnexus, and then we'll cover some questions. So with that, Aniket, I will hand it over to you.
Great, thanks, Caroline, and welcome everybody to the DNAnexus Essentials webinar. The goal for this webinar is to just cover the DNAnexus platform and its capabilities of running your NGS workflows in a secure and compliant environment. The first slide that I have here is the DNAnexus platform architecture. This gives us a very high-level layer cake of what the DNAnexus platform comprises of. So as you can see on its boundary, you have a very strong, or we have a very strong security and compliance boundary that enables you to run your NGS workflows effectively in the cloud. We have a very strong secure and compliant foundation, which comprises of a FedRAMP moderate certification, as well as the ISO 27701 certification as well. We also provide 24/7 support, as well as continuous integration and continuous development, as well as stress testing. So a secure and compliant foundation forms the basis of the DNAnexus platform, within which you can run your NGS analysis in the cloud. On the second layer, you can see we provide support to the most commonly used frameworks in the bioinformatics and genomics community. So if you're using Docker to maintain your dependencies, you can use the DNAnexus toolkit to manage the same dependencies within the DNAnexus platform. We also realize it's important to support the commonly used workflow languages in the cloud. So you can see we support both common workflow language and workflow development language. What this means is if you have a workflow written in WDL, for instance, you can port that into DNAnexus using the DNAnexus command line toolkit. For the data scientists and the translational bioinformaticians in the room, we also provide support for either Jupyter Lab or for R. So if you have exploratory data analysis to be performed on downstream data, you can do that within the DNAnexus platform. We'll be covering these concepts as well as the scalability using Spark backend in our subsequent webinar series. So this webinar will be focused on just the essentials, but the DNAnexus platform provides you a lot of flexibility in porting your own pipelines, as well as doing downstream exploratory data analysis. The third layer that I want to talk about is the projects layer. A project is basically a secure and compliant boundary that enables users to share either workflows, apps, data, or containers in the cloud. It kind of enables users to collaborate in a secure and compliant environment. You can also analyze structured data as well as visualize the end product from your workflows within a project. We also provide business intelligence-like support for your data files that are created in the downstream of your project. On top of the projects layer cake, we have a single layer of API that enables a user to interact with the platform. There are three basic ways you can interact with the platform. You can use the user interface, which we'll be covering extensively in this demo. You can use the command line interface. For the folks who are familiar with Linux command line, you can use the same familiar Linux tools to interact with the DNAnexus platform using the command line interface. For bioinformatics developers who would like to develop their own tools on the platform, you can use the software development kit, which is either in Python or Java. This kind of enables you to bring your own applications and develop on top of the DNAnexus architecture. And finally, we have uh, apps and adapters that integrate with either upstream or downstream pipelines. These might be LIMS systems in the upstream or maybe EHR systems on the downstream. Different cloud service providers also can be integrated, or data can be integrated from different cloud service providers using the DNAnexus API. So using those building blocks, we kind of enable the development of solutions for either secondary analysis, translational informatics, clinical trials if they have a GXP requirement, or customized communities. We'll be talking a little bit more about these solutions in the subsequent slides, but for now, let's just dive right into the DNAnexus UI platform and walk through a very simple use case in which we are going to run and analyze some data. So I'm just going to exit out. I'm going to navigate to my browser. So right now I am at platform.dnanexus.com within my Chrome browser. If you haven't created an account, you can go ahead and create an account by clicking on the create an account link, which should take you to a page such as this. It's a very brief one pager that would ask you for your personal information as well as your account details. Since DNAnexus is multi-cloud, multi-region, you can also choose an underlying default cloud region. And once you hit I'm not a robot and hit create account, you can create an account on DNAnexus. So creating an account is pretty simple and it just takes about 2 minutes. Since I already have an account, I'm just going to go ahead and sign in. I'm just going to get logged in. For this specific account, I have a two-factor authentication that's enabled. So I'm just going to type in my two-factor authentication code. 5618. This is an optional feature that can be enabled for any account on DNAnexus, which adds an additional layer of security to log into the DNAnexus system. We also provide support for single sign-on if your organization supports or requires a single sign-on system. Once you log into the DNAnexus platform, you can see a list of projects. Again, the project is like a folder within the cloud, which gives you very specific access privileges for a user or a group of users. So each project can be thought as a folder within DNAnexus with some amount of metadata associated with it. So you can see I have several projects that I have access to. The metadata associated with this project shows me the total data within this folder or within this project, the access privilege level. So I am an admin on several projects as well as an uploader on several others, the number of members that have access to the contents within a project, as well as several other metadata features. You can also turn on and turn off these metadata features, such as I can add in the regions tab that shows me the region in which this project is available in. Since DNAnexus is multi-cloud, multi-region, you have the same experience across different cloud service providers and different regions within the same cloud service provider. As you can see, this project is in a different region called Azure West. For my next step, I'm going to go ahead and create a new project. Say, for instance, I have an experiment that I would like to perform within DNAnexus, and I have some whole exome sequencing samples that have come in from the lab. So let's just call this project as WES samples to test. While creating a project, I have the option of selecting the underlying region to run my analysis on. This kind of gives our users the flexibility of running the same analysis and having the same look and feel across multiple cloud service providers. So as you can see in the dropdown, I have several regions within AWS and Azure. I'm just going to stick to my default region, which is AWS US East. I also have the option of selecting the build to, or who gets billed for all the analysis and the storage for this specific project. This can be a single user in this case, or it could be an organization which has a single billing account. So I have the option of selecting my bill to account while creating a project. Below the general tab, there is a metadata tab that gives you the ability to put in your own customized metadata. So if you have a metadata schema that you would like to enforce across the organization, you can add in specific tags. You can add in a project summary saying these are whole exome sequencing samples that needs to be processed. I can now add a project description. This is really helpful for folks who would not know what the contents of a project were. So they can just go ahead and read the project summary or the project description and then figure out what analysis or what was the purpose of setting up this project. Below the metadata tab, you also have project-specific access policies. So you can enforce these access policies either while creating a project or while a project has been created. So I can enforce saying, I do not want any members to download or delete any of the data within this project. This can be turned on and off based on your requirements of setting up your data. So let's just leave the access policies as default and hit create project. Once I hit create project, it creates an empty folder within the project with no data in it. So the next question would be, hey, how do I get data into DNAnexus's platform? So there are various ways of accomplishing this. Most of our users use the command line toolkit to stream large amounts of data, either FASTQ files or BAM files, into the DNAnexus platform. Some of our users also stream data from uh, external cloud service providers. We support those as well. But for the purposes of this demo, I'm just going to cover the 3 different ways of pulling data using the user interface. So I can go ahead to the new tab right here and click down on the drop down menu. The first and the most easiest way is to upload data directly. If I click on the upload data tab, I can drag and drop files into this window and click on upload to add data into DNAnexus. This is the most easiest way of pulling data into the system, but it's only recommended for really small files. If it's a large number of FASTQ files or BAM files, we would recommend using the command line toolkit, which will be covered in more detail in the next webinar series. The second way of getting data into the system would be to add it from a server. So if I click on add data from a server, I can provide a valid URL link and click add data, and that would pull in the valid URL into the DNAnexus platform. I can add in several different URLs, and it would also do a check on the actual URL file format to see whether it's a valid URL before pulling in data into the system. So if you have a new release of the Cosmic dataset, you can add in the link for the Cosmic dataset in order to pull it into DNAnexus. The third way of getting data into the DNAnexus project would be using or copying data from a different project that I have access to. As a user on DNAnexus, you would have access to several open projects as well as projects shared by different collaborators. I'm just going to navigate to a folder or a project called as demo data, which I have access to. I'm just going to click on the demo data project. I'm going to select all the files under this project, and I'm going to hit copy. And as you can see, the DNAnexus platform has copied all the selected files within my project pretty much instantaneously. The reason for that is some of these files might be or are pretty large. The reason for these files to be copied so fast was because we do not physically copy files in the DNAnexus platform, since all the data within or all the objects within the platform is immutable and tracked. We only can copy the references for those files or those objects in the platform. How does this help our users? This helps our users uh, by reducing the need for duplication of data on the platform, and hence that would reduce your storage costs as well. So you can create multiple projects and have the same files across multiple projects, but you'd be only paying for the storage cost of the original file that was stored on DNAnexus. The next thing that I want to go over is investigate some of the files that we actually copied into the project. So within Quick Start, you can see I have two FASTQ files. These are reasonably small FASTQ files. So I'm just going to go ahead and click on one of these FASTQ files. And you can see for all objects on DNAnexus, we capture a lot of default metadata associated with this project or with this object. You can see the default metadata displayed on your right hand side. You have the name of the file, the unique file ID. This ensures that the file is immutable and is tracked across different analysis. You have the path to the specific file, the state in which the file exists, the type of the object, which is a file, the total size of it, as well as additional metadata features on when this file was created and when this file was modified. You can also add in your specific metadata. You can call this file as a test, and this would add a test tag. You could also add in key value properties if you have uh, more contextual metadata coming in from a LIMS system, for instance. So you can add them right here. Uh, by adding your customized metadata, you can search on the same metadata that we've added here, and this would help you search through or sift through a large number of files if you have a consistent metadata schema that's imported. You can also add in your metadata while uploading these files from the command line if you have the metadata in a JSON format. So the DNAnexus system, the DNAnexus platform enables users uh, to track uh, their files uh, across different users. So we've created a new project. We've added some data into the project. We've investigated the metadata associated with some of these objects. The next thing that I would like to do is run an analysis using these input files. For that, we can go right on top to the Tools tab and click on the Tools library right here. When I click on the Tools library, it takes me to a library of apps or workflows that have been made available by DNAnexus or our collaborators. This again is not an exhaustive list of all the applications or tools available on DNAnexus. This is just an example list. So users such as you can use these tools, or you can modify and upload your own tools on the platform. You can go ahead and select or filter these tools based on their category as well. So if I'm interested in RNA-seq, I can just click on RNA-seq, and that would pull up all these tools that are associated with any kind of RNA-seq analysis. There's further contextual metadata provided for each one of these tools, including their version numbers, who uploaded the tool, which region is it available in, and the category of course. Since we have some FASTQ files, let's just go ahead and navigate based on one of the most commonly used aligners called BWA. So I'm just going to search on the term BWA, and that pulls up both a workflow as well as apps associated with the search term BWA. I would like to run the BWA FASTQ mem read mapper. So I'm just going to click on the BWA mem FASTQ read mapper, and that should take me to the info page for this specific tool. So since this is a public application, we provide a lot of information and README about this specific tool. So you can read through the README that tells you what this specific application does, how do I run it through the command line, which regions is this application available in, and what's the change log for the latest version for this specific application. For the command line savvy folks in the room, you can also run the application through command line and batch this for a large number of samples. So there's a lot of information that's provided for this specific application as part of the DNAnexus tools list. You can also go to the versions tab and revert back to an older version if you would like to have consistency in terms of versioning for running a specific application. So let's go back to the info tab and just click on run analysis. That pulls up my all projects tab, in which it asks me to select a project to run the specific application. I'm just going to select whole exome sequencing samples test, the project that we just created right now. And this pulls up a runner pane that shows me my required inputs on my left of the tool and the expected outputs for BWMM in blue on the right. So you can go ahead and select the FASTQ files by just hovering over the required inputs. So this says I would need either one or an array of gzip FASTQ files to satisfy the required input, which is in orange here. So let's just go ahead and select a FASTQ file. I can navigate to the exact FASTQ files that we were investigating in under quick start. So I'm just going to select the first paired end. The second paired end is an optional parameter, but let's just go ahead and select that as well. You can also select multiple files by clicking on the select all tab, but since this is just one file, we're just going to select this second mate. The last required input is the actual BWA reference genome. So here we're going to map the reads against a known reference genome. So let's just go ahead and select the reference genome. Let's select the UCSC HG19 BWA reference index. And once we selected all the required inputs, this app says that it's ready to be run on DNAnexus. But just before we run the app, let's just go ahead onto the settings tab right here. And once we click on the settings tab, you can see the list of parameters that are provided to the user for this specific application. We can see a README on the left-hand side, as well as a list of parameters for BWA on the right. So we can go ahead and select or change any of these parameters based on our analysis requirements. Since DNAnexus provides an SDK, you can download the internals for any of these applications and change these parameters to the defaults that you would require for your analysis. So any application on DNAnexus is flexible, and you can develop your own parameters on top of that as well. I'm just going to leave these parameters for default. The only parameter I would like to go ahead and review is the underlying instance type to run the BWMM FASTQ read map application on. So I can go ahead and select the drop-down list for configuring an instance type. If I would like to select an underlying instance that has higher memory, I can go ahead and select an instance with larger memory. with more storage, as well as with more cores. So this gives you a lot of flexibility in running an analysis without actually having to worry about the orchestration of spinning up a new instance, copying the data, as well as spinning down a new instance once the analysis is complete. All of that data orchestration is taken care by the DNAnexus platform on the back end so that you can focus more on your science. So I'm just going to leave my instance type as default for now and go back to the runner tab. Since I'm satisfied with the parameters for the BWMM FASTQ read mapper as well as the input files, I can go ahead and select run analysis. And once I click run analysis, it takes me to the monitor tab, which provides a list of all the jobs submitted within the DNAnexus project. As you can see, there's some metadata associated with the job as well. It shows me that I've just deployed a BWM FASTQ read mapper application using an executable with the actual version number. It also gives me full traceability in the sense it shows me who launched this application, when did it start running, how long has it been running for, as well as the real-time cost estimate for this application. So you can go ahead and set cost limits, or in fact, time limits for any one of these applications as and when you desire. You can also go ahead and terminate any application by clicking on the terminate tab right here, or you can go ahead and terminate all the analysis within a specific project. So the DNAnexus environment provides full transparency and full traceability for all jobs run within the DNAnexus platform. Let's just go and explore this job a little bit more detailed by clicking on the job ID. Once I click on the job ID, it takes me and gives me more contextual information for this job. So it has a unique job ID associated with each one of these jobs. It gives me the exact time and date when this application was launched. It also has links to the underlying executable used, as well as it gives me a progress bar of how much time has elapsed since the application is running. Since we have full traceability and full provenance built into the system, you can always go back to the input files that were used for this application. So all your jobs run on DNAnexus have full provenance so that you can track exactly what application was run at what time and by who. Finally, for the folks who are interested in the actual log files and for debugging failed jobs, you can click on the view log file right here, and that pulls up the underlying logs for BWM FASTQ read mapper. As you can see, it's giving us the real-time logs of the actual mapping step that's been happening on the background. Like you can see, the application is finished running, and we have the output files as well. So you can go ahead and click on the output files, and that should take you to the underlying output files, or the BAM files that were created by running the BWM MEM FASTQ read mapper. You can go ahead and download one or multiple output files by selecting the download tab right here. Once you click the download tab, you can either download these files individually, or you can get bulk URLs to download them in a more programmatic fashion. If you'd like to share files with a user that is not on DNAnexus, you can also get the URLs for each one of these files, and you can share these URLs, which would be active for the next 24 hours to anyone who has access to this specific link. So this kind of gives you the ability to share the results for any application or any file within DNAnexus with an internal or an external collaborator. For most analysis in bioinformatics, you would need one or many applications strung together. For that purpose, we have a workflow framework that enables our users to string together one or more applications in a more programmatic manner. We are going to create a new workflow using the UI by clicking on the new workflow tab right here. Once I click on the new workflow tab, it pulls up a blank canvas for me to create my own workflow. So let's just go ahead and give it a nice valid name. Let's just call this BWA freebase, which is a very popular variant color as well. So I'm just going to go ahead and click on add step. I'm going to filter for BWA. That should pull up all the tools that match the term BWA. I'm just going to select the same application called BWA FASTQ Read Mapper. Now I'm just going to select a variant color called as freebase, which is a very simple variant color. I'm just going to add freebase to my workflow list. And I can keep doing this for multiple applications based on my analysis requirements, but let's just stick to 2 apps for now. As you can see, I've added 2 applications right here. One called BWM FASTQ Read Mapper. The second one is a variant color called Freebase. What I'm going to do right now is string together the inputs, the outputs for the first application as the input for the second application. So I'm going to take this BAM file. I'm going to drag and drop this to the input file for the second application. That creates a link so that the output files from the first application gets linked to the input file for the second application. I'm just going to go ahead and satisfy the input requirements really quickly. Let's just go and select the read files, the second pair. Let's go select the reference files for the BWM FASTQ read mapper, as well as the reference file for Freebase. So let's just go and set the same type of reference file. And once I've satisfied both the inputs for both the applications, I can run this as a workflow. So let's just go ahead and hit start analysis. Once I hit start analysis, it does a validation for all the inputs and the outputs. And once the validation is successful, I can click on run as analysis. And once I do that, the system submits a job as a workflow in which we have 2 separate steps. The first step is the same step that we ran before, called as BWM FASTQ read mapper. And once the outputs of the first step is available, the Freebase variant caller will run after the first application. So this gives you, the user, a mechanism of creating your own workflows by defining your own logic, as well as creating your own applications as and when you deem fit. While this runs, let's just go back onto the Manage tab, and we've created some applications here. We've run a very simple application called as BWM FASTQ read mapper. We've also created a workflow in which we strung together 2 applications, BWMM and Freebase. The next thing that I would like to do is share these files, all the results associated with my collaborators within DNAnexus. And for that purpose, I can go to the top right-hand side, called as the Share tab right here. And this pulls up a Shared Project tab that enables me to share all the contents within a specific project with one or many different users. So I have a different account under the name of Aniket D. Once I add the username for that specific account, I can also select the access privilege level for this specific user to view the contents of this specific project. So I can choose, based on the dropdown, a viewer in which this user can only view and download data within a specific project. I can give this user an uploader privilege in which they can upload but cannot run or edit any analysis. I can give a user a contributor privilege in which they can run analysis, but they do not have any administrator functions. This is basically for bioinformaticians who would like to have their own analysis or develop their own tools on the software or on the project. Or finally, I can add in an administrator in which you have all the admin privileges within a specific project. So let's just go and add this specific user as a contributor and click add member. You can also add an entire org uh, to a specific project. So anyone associated with a billing account or an org can be added to a project as well. You can also go ahead and remove any user. Since I have the administrator privileges, I can go ahead and remove a specific organization and all members associated with that organization as well. So the share project functionality gives us a really easy way of sharing and collaborating results, data, applications, tools, all within the project framework in DNAnexus, without having to duplicate multiple data types on the cloud. So this kind of enables you to do sharing and collaboration in a very effective manner. Finally, once I've shared this with multiple users, the last thing that I would like to go over is the visualization tab, in which we've made available the most commonly used visualization tools on DNAnexus. So if you would like to visualize the FASTQ files within a specific project, you can go ahead and select the open source available fastq.bio visualizer. The only thing that one needs to take care of is the data is streamed directly into these open source visualizers. So if you're comfortable in sharing data outside the platform, I would suggest using one of the inbuilt visualizers within DNAnexus. And finally, once we've run our analysis, we can go onto the settings tab within the DNAnexus platform for an overview of what was actually achieved within this specific project. We give you an estimate of the total storage cost per month, as well as the total data stored within a specific project. We also give you a lot of contextual metadata associated with this project. So you have a unique project ID, you have tags associated when we created the project, as well as the ability to transfer this project to a different user, provided the user accepts the transfer. So if you're changing institutions, or if you would like somebody else to pay for the contents of this project, you can always transfer this to a different user. You can also change the access policies, the copy policies, as mentioned before, which gives you a lot of flexibility in sharing, as well as preventing your data from being shared with different users. Great. So finally, I'm back onto the Manage tab. Let's just review what we've done on DNAnexus. We have created a new project. We've gone over the project concept on DNAnexus. We have imported some data or copied some data from a separate project into the DNAnexus project. We've also inspected an object as well as the associated metadata with that object. We've gone over the tools list, in which we've gone over all the tools that are available within the DNAnexus environment. We've run a tool as well as a workflow in the form of PWMM and Freebase. And finally, we've gone over the visualization tools that are available on DNAnexus's platform. That kind of gives us a very high level overview on how you can use DNAnexus's platform to run a very simple basic analysis. This covers the UI essentials using the platform. Uh, there's a multitude of things that you could do in developing your new apps, running multiple apps as a batch analysis using the command line options, which would be covered in the subsequent webinar series. And with that, I would go back to my PowerPoint right here. Quick mention about documentation as well. For users who would like to try out and give the platform a go, we also have online documentation, which covers what we covered in the webinar so far, as well as a lot of additional documentation on the CLI and the SDK. So I would highly recommend you to go to documentation.dnanexus.com. If you click on that, it takes me to an online documentation page with a getting started page with multiple videos, as well as frequently asked questions. So I would highly recommend anyone who would like to use the system to take a look at the DNAnexus document page as well. Finally, moving on from the documentation page, a quick note about the Xvantage group. DNAnexus is a platform company, but we also have bioinformaticians on staff. So if you would like to work or collaborate with us in deploying and developing pipelines, the DNAnexus Xvantage group provides a wide range of professional services that helps you accelerate your research using the DNAnexus platform. So we would really like to work with you to understand your needs and get your workflows up and running in the DNAnexus platform. Some of the services that we provide as part of the Xvantage group is customized workflow development and workflow portability. So if you would like to run some of your on-prem workflows on DNAnexus, the DNAnexus Xvantage group and our bioinformaticians on staff would be able to help you deploy those workflows in a more scalable environment such as DNAnexus. We also provide data harmonization services in which we can harmonize your own data types onto the platform. If you also like a very specific look and feel for the front end, as in Precision FDA or the St. Jude Cloud, we also provide portal customizations in which we would develop a very customized UI as well as a very customized user interface for your analysis for external customers. We also provide GXP compliant clinical trial pipelines if that's a requirement for your analysis. We provide genome assemblies as a service. So if you would like us to assemble a genome on the DNAnexus platform, that is also a service that we provide as part of the Xvantage group. And finally, we have on-site training as well as customer care support for both your IT, your bioinformatics, as well as your technical needs. So the DNAnexus Xvantage group provides a wide range of services that enable you to run your workflows in a scalable environment such as the platform. And finally, I would like to move this or hand it over to Caroline, who would give you more information about the next webinars that are coming up. So Caroline.
Sure, thank you, Aniket. As Aniket mentioned, I would like to highlight our newest webinar series, Tips and Tricks of the DNAnexus platform, using WDL and Docker to develop locally and scale to the cloud. Please note that this is a two-part webinar series, so attendees will get the most out of it by attending both sessions on October 24th and November 7th. If you cannot attend both sessions, you can register anyway, and we'll be sure to send you the recording. You can register and from there, I'd like to move on to any questions. Aniket, can you advance the, thank you. As a reminder, if you do have any questions that came up out of today's webinar, please type your questions in the Q&A box at the bottom of your screen. Aniket, the first question I have for you today is, how can I import my CWL workflow to the platform?
Great question. So the DNAnexus platform or the DNAnexus toolkit has support for CWL. So if you're comfortable in working with this, if you have a workflow written in CWL, I would suggest taking a look at the documentation as well as the DNAnexus toolkit that converts your CWL workflow into a DNAnexus workflow, and you can run that DNAnexus workflow on the platform itself. So CWL and WDL would be covered in the subsequent webinar series, which is a more advanced webinar series that gives you a lot of command line tips and tricks for running your WDL or CWL workflows on the cloud.
Great, thank you. The next question, using the share project, can we import an AMI from an AWS platform? Also, can we retrieve an external S3 bucket from an AWS account using the S3 importer?
Great question. I'll take the second one first. DNAnexus provides applications called for pulling data both from Microsoft Azure's blob storage as well as DNAnexus or your own AWS S3 account. You can use the application and provide your AWS token that as well as the file path. Once you provide your access token as well as the file path, the application pulls data directly from uh, your personal AWS S3 bucket into DNAnexus's platform, which runs on S3. So that complete process is automated using the UI, but you can also run that through the command line. The second part was about the AMI. DNAnexus provides support for running your own instances and all the dependencies. So I'm not sure whether you can import an AMI from AWS, but you can spin up your own instance and SSH into it with all the dependencies using DX Docker. So yeah, we do provide support to pulling data both from AWS as well as managing dependencies on DNAnexus.
Great, thank you. In which platform is the workflow downloaded? In which format is the workflow downloaded from the platform?
So if you download the workflow from DNAnexus, DNAnexus has its own format, which is based on JSON. All the internals for the workflow are open to any developer for them to develop. I would take a look at the DNAnexus documentation under the developer resources, which would give you an idea of the actual format and how to develop your own applications on DNAnexus. But the underlying format is JSON.
Okay, great, thank you. How do I get data into the platform from non-standard HPC systems?
Great question. So DNAnexus provides, or we provide you with the command line API. So you can install that on either a Linux system or a Windows system or a Mac OS in my case. The actual CLI gives you the ability to stream data in a more programmatic fashion directly into DNAnexus. If you mean non-standard HPC as in Windows, we also have a Windows version of the CLI that enables you to stream data directly or import data directly into DNAnexus. More of those techniques will be covered in the subsequent webinar series in which we'll be going over tips and tricks in order to import data into DNAnexus.
Perfect, thank you. And how do I track costs on DNAnexus?
Good question. So tracking costs, you can track costs either using the monitor tab as we've displayed before. The monitor tab tracks costs that are associated with compute. So you can see all the costs associated within a specific project that are related to compute. For storage, you can go to the settings tab within the project framework, which gives you an estimated cost for the storage for a specific month. So you can track both compute and storage within DNAnexus. You can also put limits on your total amount of spend at an org level so that you can say, hey, I just want to spend about $10,000 in compute and storage for a particular organization. So we provide those cost controls as well. We also provide fine-grain cost controls for each job. So you can put limits on how much a job is allowed to run, or how long a job is allowed to run in case if a job keeps running for more than the expected time. So you can say, hey, I would like to time out a specific job or a specific analysis at 6 hours, and the job would terminate after 6 hours. So there are several ways of managing costs. Our We try to be as transparent as possible using the UI so that you can track both your compute and your storage costs on DNAnexus.
Perfect, thank you. A couple more questions. Does DNAnexus have any public data sets available for analysis?
Good question. So in terms of public data on DNAnexus, we provide the most commonly used reference genomes as part of a public project, which is accessible to all users who sign up. We also provide the UK Biobank data. So if you're an approved user for UK Biobank, you can access your copy of the data through DNAnexus through a product called as DNAnexus Apollo. So this kind of accelerates your analysis of the UK Biobank data by accessing a harmonized copy through DNAnexus Apollo for your UK Biobank datasets. We are in the process of making available several open source datasets as well. So I would highly encourage you to revisit the DNAnexus webpage to see what datasets are available.
Okay, great, thank you. And then the final question that we'll be able to get to live today, I know we have a couple others that we can follow up directly via email, but the final question is, are there any apps on the platform that are ready to use?
So all the apps that we displayed in the tools list are ready to use. There's a lot of README information that's given on how to run the application, both on the UI as well as on the command line. There might be some applications which might be private to specific users, but all the public apps that you saw on the platform are ready to use. Just a quick note to that. If you do not find an app that you would like to run on DNAnexus, please reach out to support@dnanexus.com as listed on the webinar, and we'd be happy to provide that app into your project as well. So we have a larger app library, which is private, in which we kind of maintain ourselves. So I would highly recommend you to reach out to us directly if you do not find a specific application that you're looking for.
Great, thank you. And as I mentioned, if we did not answer your question today, we will do so via email. We appreciate everyone for taking the time to join us in this webinar. Aniket, thank you for giving a great demo. Again, we encourage you to register for our second webinar using WDL and Docker to develop locally and scale to the cloud. And you will find information about subsequent webinar series on DNAnexus.com/Advantage group. So you'll be able to see all the different tips and tricks that we're sharing on that page. And look out later this week for an email with the recording of this webinar. And we appreciate everyone's time today. Thank you, Aniket.
Thanks, guys. I hope this was helpful. Bye-bye.
Bye.